Okay, welcome back to the video lecture series on network theory. This is lecture number 52 and we are into module number 4, sorry. Okay. So in the last class, we discussed about inverse Laplace transform basics, right? How to find the roots. So by using the partial fraction method, okay. So today in this class, so we will be discussing 2 or 3 basic problems based on the previous class, that is partial fraction method. So there we have already discussed what you mean by cover up method, and these are the required things so which we will use while analyzing the circuit elements. Okay. So next we will also discuss about how the circuit elements can be represented in Laplace domain or in the frequency domain. Okay. So then followed by some waveform representations or the possible operations which can be performed on the waveforms. So once you are aware of these things, so then once we take up the problems, so then we will not face any difficulties. Okay. So now let us start with the first problem here. That is, we need to find the Laplace inverse Laplace transform of the given function. Okay. So in the last class, we have discussed about cover up methods, right? So there, what I told you before the cover up method. So first, if you look into the given equation or given function f of s, so from that, first you have to determine whether it is a linear or linear repetitive or quadratic repetitive or linear or distinct, right? So which kind of equation it is? So which kind of equation it is? Linear. Okay. So can you tell me which kind of equation it is now?
Linear.
Yeah, it is
Linear.
linear equation, right? So from mathematical background, so you should be able to grasp it anyway. So linear means what? Linear and distinct it is, right? So we have 1 by s and s plus 1 and s plus 3. So it is just like s plus 0 instead of s. Okay. So the denominator factor is changing linearly. You may have minus also. So let us not go into details of that. Again, it will be the part of mathematics. So just you have to remember here how to get the roots. So you can get it by a by s, then b by s plus 1 and c by s plus 3. So to find a by cover up method, so what I told you, you just equate this to the original function and check whether you are able to cancel the denominator of a variable. So once you are able to cancel that, and a will be equal to 0. When it will be equal to 0, so if you select it, so if you put that value, so what you will get is a is equal to 2 by 3. Okay. So assuming that a is also 0, because 1 by 0 again it will be some infinite form. So assuming a suitable condition here. Okay. So similarly, if you equate b divided by s plus 1 equal to here, so this term and this one is going to cancel out, and we know b is equal to 0 when s is equal to minus 1. So if you put s equal to minus 1 here, so in this term over here, So what you will be getting is b is equal to minus 1 divided by 2. So I hope you can check out that. So similarly, c divided by s plus 3, if we equate, so this term and this term will cancel out, and we know, so this will be 0 for s is equal to what? Minus 3. So if you put that value here, minus 3 plus 2, that will be minus 1. So minus 3 plus 1, that will be minus 2. Minus 2 into minus 3, that will be 6. So here minus 1 is there and divided by 6. So that will be the value. So this is the shortcut method, and it is applicable to certain conditions only. Okay. So we have already noticed the limitations of this method, right? So it is applicable to linear, and as well as if there are repetitive terms, so only to the highest power we can apply. So here anyway, power is uniform, so it is applicable. So till here we used to write. Now if you substitute the value of a and value of b and value of c in this equation, so you are going to get this equation, right? So here 2 by 3 is a constant, you take it outside, you take the inverse Laplace. So L to the power minus 1 means it is inverse Laplace of 1 by s, inverse Laplace of 1 divided by s plus 1, inverse Laplace of 1 divided by s plus 3. So those things will give you these results, 2 by 1, and 1 by s inverse Laplace is 1, we know already, right? Okay. Or in other way, Laplace transform of 1 will be 1 divided by s. Okay. So this is the required basic thing. Basically, you should be equipped with these things, or you should be able to solve all these things before you take up the problems. Okay. And sometimes you may get these kind of problems also. Okay. So in the question paper, they have asked for around 5 to 6 marks. So you may get it. Okay. Yes, is it clear now, everyone?
Yes, sir.
So
Yes, sir.
based on the similar method, if you take this here, this function, that is s plus 2 divided by s square into s plus 3. So now something is repeated. So it is a linear one, but anyway, it is repeated. So we can take repeated roots, repeated fractions here, a by s, b by s square, and c divided by s plus 3. Okay. So if now by cover up method, we cannot, it is not applicable to this ratio. Why? Why?
I,
Yes.
the
Yes.
square is there.
S square is there. So since this is repeated, so we know it is applicable only to the highest power, and this is applicable to this as well. So by cover up method, we will be able to evaluate b and c values only. Okay. So you can equate b to find b, you know, s square will get cancelled out, you will get this. So if you put s equal to 0, you will get b equal to 2 by 3. Okay. Yes, are you all following this?
Yes, sir.
Yes,
Yes,
sir.
sir.
So once you are able to get b and c, now take the original equation, that is this equation, then put the values of b and c. So you need to find the value of a. So start from 0. So if you put 0, so this ratio will be again indeterminable form. So take any other value, s equal to 1. So if s is equal to 1, so you should not get any issues. Okay. So what you get is, if s equal to 1, you will get a is equal to 1 by 9. So you can solve that. Okay. And once you solve till here, nothing else, nothing will be left. Only substitute and take up the equivalent inverse Laplace transform. So no need to remember all the inverse Laplace here. So if you get 1 divided by s plus 3, it is e to the power minus st we have seen, or at. So a value is plus 3 or t naught you can take, right? So if you do those things, so you will get that. So it is like t to the power 1. We know already it is 1 by s square, right? So just take the reverse values here. Okay. And this is as good as it is t to the power 0, which will be 1. Okay. So I hope you are getting these things. So one problem I will leave it to you, but I have just given you the ratios or the fractions here. That is, this is the given function. So how to split in terms of partial fractions? So we'll get, this is independent, a divided by s plus 1. This is repeated, b divided by s minus 2. Then c divided by s minus 2 whole square. Okay. So just try this by yourself. Okay. And if you go to the fourth one, inverse Laplace transform of 3s plus 1 divided by s plus 1 into s square plus 2. So now it is not quadratic also, means it is not linear also. So you will not be able to find these roots properly. Here you may get like s equal to 1. So I am telling, I will be telling you here a different method. So listen carefully here. So that is, you follow your as usual method. That is, you multiply throughout by this, what we have. Okay. S plus 1, s square plus 2 on both LHS and RHS numerator. So you will get this equation. Okay. So you just cross multiply, means you just expand these terms. So you will be getting this. So this will be is equal to 3s plus 1 only. So in this equation, if I call this as equation 1, in equation 1, if you compare coefficients of s square on to with this side here, coefficient of s, and coefficient of s naught means this one, s to the power 0 will be 1, right? So if you compare with hand in hand, what you can get is a plus b. There is no s square term, so you can write a plus b equal to 0. Then b plus c, s term is there, that is 3s. So b plus c is equal to 3. Then 2a plus c will be equated to 1. So if you solve this, you can use the calculator also, you will get this. So then substitute, then you will get the required values. Okay. So sometimes you may not get in the standard form. So suppose here like s square omega naught square, it is not there. So you have to adjust it, root 2 whole square. So it is now in the form of s divided by s square plus omega square, which is nothing but your cos omega t, right? So you can take omega equal to root 2. So I have told you 3 methods of solving the partial fractions. So whichever is applicable to that particular problem which you may face in the examination or somewhere else. So remember it. Yeah, is it clear now? Any questions here? Yes, is it clear now?
Yes, sir.
Yes.
So fine. Now see, I am just giving you the basics here. You may be thinking that we have spent already 4 or 5 classes on this. Okay. So but these are the basic requirements. Even though if you know or don't know, it doesn't matter, but I really want you to be equipped with these things. Okay. So next is, now we are getting into the track of circuits here now. So now if you take the Laplace transform of electrical elements, so electrical elements means RLC and also your voltage source and current source as elements in the electrical network. So you can have the variables as voltage and current in the network elements, voltage and currents with respect to the network elements R, L and C. Okay. So out of this, if we consider voltage and current variables, any network, assume any network. Okay. So there, if you assume that in time domain V of t and I of t, if they are representing V of t and I of t, if they are representing some source or response, V of t may be the source, that is input, I of t can be the output, that is response, or I of t can be the input, due to which you may get V of t also. Okay. So in general, how do we write it? The Laplace transform of voltage in time domain with respect to frequency domain. So Laplace transform of V of t, generally it is taken as V of s. Okay. And similarly I of t will be considered as I of s. Okay. So wherever you get simply V of t, so that you may consider it as what here? Its Laplace transform. It will be V of s. But if we have some variables before this or below this, so that may change the representation. How we will see here. So if V of t is 2 volts, so that means in the elements in the circuit, it will be given like this 2. 2 is a constant, and we know what is the Laplace transform of a constant. It will be constant divided by s, right? So V of s will not be only V of s. V of s will be, it is 2 divided by s now. Okay. Yes, are you getting this, everyone?
Yes. Yes, sir.
Okay. So similarly, if you take I of t, current source in the circuit, if they mention the current source value as 2t, if it is 2t, which is equal to I of t, so then what will be I of s? 2 is constant. And what is the Laplace transform of t to the power 1? It is 1 by s square. We have seen already, right? So that will be 2 divided by s square. So if the input is 2 into e to the power minus 5t, so V of s will be 2 divided by s plus 5. So it is as good as 2 into 1 divided by s plus 5. Okay. So check out these things. Is that clear now about these 3 examples?
Yes.
Okay. So don't keep any doubts in your minds if you have any doubts, because again already we have derived it initially. So this is the reason why we are dealing with standard functions of the Laplace transform initially. Very first class only, if I tell you all these things, V of s is equal to 2 by s, then how do you understand it? So it will be difficult. So basics are very important. So if you know the basics, then you can deal any circuit here. Okay. So that was about the sources. Now if you take the elements, circuit elements R, L and C. So first, if you take the resistance, so if you assume that resistance of R ohms in time domain, it is R ohms is connected across a voltage source of V of t, which is producing the current I of t. So by normal, what you say, the KVL equation, you can write V of t equal to I of t into R, right? So its Laplace transform will be what? V of s equal to I of s into R, right? Okay. And if you evaluate for R, so you will get this. So if you are interested in impedance in the S domain, that will be V of S upon I of S. And if you take the admittance or conductance, so that will be I of S divided by V of S. Okay. So next, if you take the second element, that is inductance. Okay. So if you take the inductance into consideration, so here inductor as an element, you can think of the capacity of the inductor. So already we know in the transient analysis we have seen inductor will not allow sudden change of current, right? So you can consider here two conditions or two cases, that is inductor with zero initial current and inductor with some initial current. Okay. So as usual, without any initial current, if you consider V of t can be defined in terms of inductor current as L into di by dt, right? So its Laplace transform will be what? L into S. So this is actually Ls into I of S. Okay, getting this? So if you solve for Ls or SL, so we'll be getting this equation, and its impedance will be what? Now it is in the form of impedance. Its admittance will be 1 by SL. Okay, clear? And now if you consider that inductor initially carries some current, so that is some current IL of 0, so then how it can be represented? So as usual, V of t you can write L into di by dt, but I of t is what? Initial current, current through the inductor, and total current is I of t. I of t is inductor current is 1 by L integration of 0 to t V of t dt, plus this is the which current? It is initial current. Yes, following this? So now if you consider the equivalent frequency domain relation here, you can write V of t as V of S. Okay, so this one we know already, Ls into I of S. Okay, so now if you use I of t here, so that is going to give you this equation. Okay, so once you get, so how do we how we got this equation here now? We know already the Laplace transform of f of t, d by dt of f of t is what? F of s minus f of 0, that is initial value. What is f of s? F of s is this equation, Ls into I of s, right? Minus initial current, so with respect to inductor, that is L into IL of 0. Following this, everyone? Hello, everyone. Are you following or no? Respond quickly.
Yes.
Okay. So now you can see them as the voltage definition with two voltage sources elements, right? So this is the current through the inductor I Ls into Is, and you can assume that this is a voltage source with this value. What is the voltage source value? Minus L into IL of 0. So that if you add it, so if you write the KVL equation, you will get back this equation, right? So that is the condition here. Okay. And if you apply the Laplace transform to this here, so you will get this equation. I of s will be equal to L will be Ls, right? Okay. Yes. Any question regarding this cell here? That is the initial inductor current and inductor value. Okay. So now current through the inductor, it is 1 by Ls, and we know already the integration of Laplace transform that will give us V of S in the standard function we have seen, right? And this will be IL of 0 divided by S. So why it is divided by S? It is a constant. IL of 0 is treated as constant. So its Laplace transform will be IL of 0 divided by S. So now you can view like a KCL equation, current definition, right? So I of S is equal to, there are two outgoing currents, I of S. So here the node voltage is Vs divided by Ls, and one outgoing current is IL of 0 divided by S. Okay. Yeah, is it clear to everyone? Following or no?
Yes, sir.
Yes, sir.
Okay. So the last element is this one, capacitor. So if you take capacitor, initially what you can assume? Some initial value, whether it can carry any current or voltage. Tell the answer. What is the property of the capacitor? Voltage across capacitor will not change suddenly, right? So you can assume initially there is no voltage across capacitor. So in such conditions, current in this circuit can be given by C into dV of t by dt, and its Laplace transform is this. Okay. But if initially voltage across capacitor is 0, so if you assume that, so then what we get is the actual capacitor value and its impedance, then followed by the admittance, that is Y of C. Okay. So now if you assume that there is some voltage across capacitor plus Vc of 0, so then how to write it? So voltage V of t, you can define it as current through the capacitor, that is 1 by C. Okay. So then integration of I of t dt plus initial value, this is Vc. Okay. So this then I of t will be what? I of t is this. So if you take the Laplace transform of equation 1, so that is going to give you equation 3. So it is a KVL equation. So write it. So if you take the Laplace transform of equation 2, so that is going to give you equation 4. Okay. So just glance this slide. So if you have any questions, you may ask. Yes, any questions here? Only 45. Yes. Is that clear? Any questions?
Yes, sir.
Okay. Okay. Now, everyone, please concentrate here now. So now, what I am going to explain you about the basic operations which can be carried out on the signals. Okay. So you may have any signal. So based on the signals, we can carry out these following operations. These will be useful in the coming problems. Okay. So basically, we can perform not only these 7 operations, we can perform more than these things also. So we will be discussing first, that is amplitude scaling, followed by addition, subtraction and multiplication, and also time related operations, that is time shifting, time scaling and time reversal. Okay. So before going to the actual operation, so if you consider this graphical notation, so horizontally we use this for time axis, right? So basically the operations starting with the name time shifting, time scaling and time reversal can be carried out with respect to the values which appear over here horizontally. Okay. But whereas if we take amplitude scaling, addition, subtraction and multiplication, so these things are usually carried out with respect to amplitude, meaning to say that amplitude value will vary here. Here time values are going to vary. Okay. So let us start with the first one, amplitude scaling. So if you consider, just a minute. Okay, so if you consider amplitude scaling, so scaling here basically refers to the some change in the amplitude. Okay, so if you consider a signal x of t, so this signal x of t, so how it is given, x of t is defined in between -1, -2, -1, 0, then 1 and 2. So basically it has been defined from -2 to 2 with respect to time. And with respect to amplitude, if you take maximum amplitude is how much? It is 1. Okay. So here if I want to just play with the amplitude here, so that means I can scale it. So I can multiply the given function with some factor here, some constant factor, right? So if I want to perform 2 times of x of t, so how to do it? So you will be dealing with respect to the each points over here. So for example, if you consider at t equal to 2, at t equal to -2, at t equal to -2, what is the amplitude? What is the amplitude? Hello everyone, are you listening or no here? What is the amplitude here at t equal to -2? It is 1 only, right? So amplitude is 1. So now what we want? We want 2 times x of t. Okay. So you are referring currently at which value? You are referring currently at t is equal to -2. So there if you multiply by 2, So what will happen to that amplitude? That will be scaled. So at -2 we had 1, so now it will become 2. Similarly at -1 it was 1 multiplied by 2 means it will be 2. So 0 it was 1, same thing. So if you rewrite the given signal, you will get like this. Okay, getting this, everybody?
Yes.
X of t means yes. Any questions?
No, sir.
Okay. So is it clear now?
Yes, sir.
Yes, sir.
Suppose if you multiply by 1 by 2, so I have given you 2x of t. If I give you half of x of t with respect to amplitude, what will happen? Now 1 is there, half of that means you will get, so just I will write it here. You will get the signal like this, right? So this amplitude will be half. Okay, so this concept you should know. Okay, now okay, so here I have written it already, you can refer it. So second operation, if I consider addition, so if for adding we require two signals, so consider x1 of t and x2 of t. x1 of t is defined from -2 to +2 with amplitude, maximum amplitude as 1, and x2 of t, it is a triangular pulse with maximum amplitude as 1. So how to add these signals? So consider the timeline here at -2. At -2, what is the amplitude of x1 of t?
One.
It is 1. And what is the amplitude of x2 of t at -2? It is 0. Right? So this is 1 and this is 0. So 1 plus 0 is going to give you 1 only. Okay. So at -2, the signal will remain at 1 only. So now you travel in between -2 to -1. So if I traverse from -2 to -1, so I don't find any signal here. It is 0. So it is same as 1 plus 0. So that will be 1 only. But at -1, again it is 1 and it is 0. Hence it will be 1. So in the same way, if you consider some midpoint here, that is at 0.5. At 0.5, if you assume it is 0.5, so it will be 1 plus 0.5, that will be around 0.5 over here. Okay, 1.5. So if you consider at 0, what is the peak value? It is 1. Here it is 1. So 1 plus 1, that is going to give you 2. So this signal will rise like this. So similarly on the other side, if you follow from 0 to 1, so it is 1 and it is 0.5. So 1.5 again. At 1 it is 1, it is 0. So it will be 1. So we will get the signal like this. Okay. Is that clear?
Sir.
Any questions? Anybody? Others? Everybody, is it clear or no?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes.
So next, if you consider the subtraction, again subtraction also we have to carry out with respect to the amplitude only. So same signal if I consider, so subtraction, how do you do it? x1 of t, this is x2 of t, this is x1 of t minus x2 of t. So start from -2. At -2, what is the amplitude? It is 0. Sorry, it is 1. It is 0. 1 minus 0 will be 1 only. So no change. So just write like that. -2 to -1, it is 1 only. Here it is 0. 1 minus 0 will be 1 only till -1 point. So at -1 it is again 1, it is 0, so it will be 1 only. Now if you just move around in between -1 to 0, so if I consider somewhere here at 0.5, at 0.5 it is 1, it will be 0.5. 1 minus 0.5 will be 0.5, so it will come down. So come to 0 here, it is 1, it is also 1, so it will be 0. Okay, so on the other hand it is 1, it is 0.5 here at 0.5, so it will be 1 minus 0.5 will be 0.5. Okay, so here also same thing, it is at t equal to +1, it is 1, so it is 0. 1 minus 0 will be 1 only. So same thing you have to continue. Is it now, everyone?
Yes, sir.
This is so if you have any doubts, so clarify that. Okay, operation on signals, it is not part of the syllabus but part of the problems, so we have to discuss it. Okay, okay, no worries. So next, moving on to the next one, that is multiplication. Same thing you have to follow, amplitude wise you have to multiply. So t equal to -2, what is the amplitude? It is 1. Here it is how much?
0.
0. This is x1 of t multiplied by x2 of t. Okay, so 1 into 0, it will be 0. So it will continue till -1, so it will be 0 only. Okay, and now after -1 to 0, if you consider here again at 0.5, it is 1, it is 0.5, so 1 into 0.5 it will be 0.5. So this is going to rise up, so 1 into 1, that will be 1, and similarly on the other hand, so it will be this. So but we will be considering this this part only, as here to here it is completely 0. Okay, fine. Okay, any questions here now?
No, sir.
Okay. Next, fifth one, time shifting. So please listen carefully here. So for time shifting, you can shift the waveform either to the right side or to the left side. Okay, so if this is x of t, so if I ask you to find x of t minus 1, okay, so how to start it? You look into the original signal. This is time axis. So if I consider one iteration, I have written it already, but just consider at t is equal to -1. Okay, so if you analyze x of t, so t value is -1 only, x of t is -1. So then if you consider, if you equate or superimpose these things, so instead of t, what we are interested in, we are interested in t minus 1. At t minus 1 equal to -1, what will be the value? Okay, so if you consider that, so then this value is going to change as -1 plus 1 equal to 0. That is, the value what you have at t equal to -1 in x of t will be shifted to t equal to 0. So this wave which was starting at -1, now it will start at 0. So similarly, if you put t equal to 0, then what will be t minus 1? T minus 1 will be equal to 0. then whatever was there in the original signal at 0, that is going to shift at t equal to 1. Okay, so if you put 1, so it will be 2. So the signal is shifted towards the right side. So if you put instead of t minus 1, if you take t plus 1, so that is going to shift the signal towards the left side. So this will go to -2, and this will go to -1. This will go to 0. Okay, so somewhere you will get the signal like this: 0, -1, -2. Understanding this?
Yes, sir. Yes, sir.
Okay. So next, last but one, what we have is time scaling. So time scaling here, if you consider, see here, in case of amplitude scaling, we had written something here before x of t. So time scaling and time shifting means this value of t, what we have, that is going to change. So if x of t is this, so we need to find what is x of 2t. So where t exists, you check it. It exists at 0, 1 and 2. So you just equate it to 2t, 2t and 2t. So that means if you take 2t equal to 0, 2t of equal to 1. So x of t, which was existing at 0, so for 2t it will remain at 0. And x of t, which was at 1, for 2t it will change to 1 by 2, right? And this will be shifted to 1. So this is time scaling, which will compress the signal. So 0, at 0 what we had 2, so it will be 2, no need to change it. So at 1 we had the signal as 2, so at 1 it was there, now it will be shifted to 0.5. So if you take that at 0.5, so you will be getting that. At 1 what we had 1, so that will be shifted to 0.5. So this signal, and in at 2 we had equal to 1, so that will be shifted to 1, right? So this is the effect of time scaling. So if you divide it by 2, it is going to expand. So how I have written here, t equal to 0, then equate it to t equal to 1 by 2t. So 1 by 2t will be equal to 0 only if you put t is equal to 1 by 2t. Okay, so whatever was there at 0, that will remain at 0. Whatever was there at 1, that will be shifted to 2. At 1 we had 1, so it will be continued till 2, so 2 will be shifted to 4. Any questions here? Any questions on this?
No, sir.
Okay, so the last operation is time reversal. So time reversal is very easy. If you have x of t as this, so what will be x of minus t? So what you can just think like a mirror image. Okay, so these are the operations, just you have to remember here. So these things we require. Okay, but we are already familiar with few signals, few waveforms, right? That is, we are familiar with the unit step function, that is u of t, which is equal to 1. Okay. Now, if I ask you based on the previous discussion, what will be minus u of t? And what will be u of t minus a? And what will be u of minus t? And what will be u of t plus a? And what will be k times u of t? So the signals, the operations, what we discussed, right? So this is which operation now? I have u of t. I am just multiplying it with respect to minus. It is what now? Which operation? Amplitude scaling. So u of t was defined at 1. So now what you get is that u of t here like this. Instead of plus 1, it will be at minus 1. Getting this? U of t is 1. You are just multiplying it with minus 1. So minus 1 into 1 means that will be minus 1 here. Getting this or no, everyone?
Yes, sir.
Yes, sir.
Then what about t minus a? Just now we have seen this. T minus a. Alright? Time shifting. So if I put t minus a, so it should come towards the right side by a times. So here what I can write, how I can represent, the amplitude will remain same. So this is u of t minus, so it is at time instant a. So this is the signal. So how to get this? How to know that signal will start at positive side instead of negative side? So originals, look into the original signal. You are performing operation on this. So this is defined at t equal to 0 to infinity. But we know at t equal to 0, at t equal to 0, it is 1. Right? At t equal to 0 it is. Okay. So we are interested in at t equal to minus a. Okay. So put t equal to t minus a. So t will change to a. So a can be anything, 1, 2 or 1.5. So it will shift here. If it is plus a, then what happens? T will be minus a. Instead of here, it will start at negative here. Getting this? And u of minus t means what? Just now we have seen mirror image. So it will be 1. So it will be occurring at minus t. And some k times u of t means what? For k greater than 1, if you consider, it is again something like amplitude you are changing, right? So if it is at 1, so greater than, if k value is greater than 1, you will get the signal like this. Yes, getting this idea here, everybody?
Yes, sir.
Yes, sir.
And in the coming classes, we require something like finding of the slope. how do you find the slope, for instance, for this signal? So since it is a parallel one, slope will be 0, y by x, right? So if you have some signal like this, what will be the slope? If it is 2 and if it is 1. Slope will be how much? y2 minus y1, or we can take directly y by x, 1 by 2, 1 by 2 or 2.
One by.
So 1 by 2. So just think on the slope also. So just if you have gone through the slope equations on the signals, so just uh, refer it. Okay. So in the Monday's class, we shall start with the problems. Okay. Okay. So we are going to end here now.